All right, good morning. I hope that everybody enjoyed their train journeys this morning. And for those of you that had issues, sorry. All right, so.
That was heartfelt.
Thank you. We'll start with, is this an Edge panel or is it a Web3 panel? And I'm going to suggest that it's inherently both. Having started with the Edge way back before it was cool in 2012, this is what it was always meant to do, is a massively distributed infrastructure, mesh, if you will, of critical infrastructure, compute, storage, interconnected to provide applications throughout, not just the Edge, but wherever the customers are. So I think it's one and the same. The four panelists we have, it's kind of cool to me because they represent every facet of what exists, from the equipment, the critical infrastructure, the networking, the services. So I'll let them introduce themselves, your place in it, and while you're there, tell me how you view the Edge and what you think it is from your perspective. So Andy. Oh, no. Oh, no, we're casual in here.
So good morning, everyone. So my name is Andy Palmer. I work for Seagate, and I hope you can hear me because I can't hear myself on the speaker, which is good news. So you may know Seagate very well for building the hard drives and the SSDs, which data is ultimately stored on, but you probably know us less for the systems that we build and the cloud service that we offer as well, which is basically a home for more hard drives, right? And this edge to core sort of structure in IT has come at us for the last few years, as you said. And for us, our customers have all got their own definition of what their edge is. But for us specifically, it's the devices, it's the endpoints where the initial data gets created. And then the compute comes from the core and sits alongside it, on top of it. And that's what our edge is.
Hello, everyone. My name is Bjornsgaard. I'm the chief exec of a business called Deep Green. You may know us from such random acts as building data centers in swimming pools. So for 7 years, we've been thinking about, as Loren says, about what the edge is and how it's going to emerge. And at the beginning of this year, we announced that we'd built a data center in Exmouth Leisure Centre. So when we think of the edge, we think of it as a place that will emerge. So I think 5 years ago we couldn't get arrested. No one was interested in having any sort of, or we certainly, when we went out to market, it was very hard to convince people that they needed a decentralized data center estate. That, I'm happy to say, is definitely changing. So the number of people and the number of businesses who've contacted us since our announcement has been interesting. And so I think Edge for us is the future where that super low latency hyperconnectivity enables all of the great things that we're going to talk about. But we are certainly in front of the puck. We're assuming that this is a 5 to 10 year cycle from now. So.
Good morning, everybody. So my name is Tobias Hooton, and I'm the CEO of a company called Stelia. Stelia is a Web3 elastic fabric connectivity platform designed to connect high-capacity Web3 workloads effectively to edge facilities. So I sit perfectly between you two here, which is very well done. My definition of edge really currently is that it's flexible. Edge means something different in every market, especially in the US and Europe as well. They are completely different definitions. I think edge for us currently is beyond regional facilities. Sites that you are building are for us what we would define as being a true edge facility. So we are drawing the differentiator between what we mean by network edge really as services right out the edge of the last mile.
Yep, good morning. So my name is Norvall. So I'm the co-founder and CEO of blocz, and we're building infrastructure at the edge, which is predominantly compute for orchestration of cloud, Kubernetes, networking. So these guys here are all in our ecosystem, helping us to build and leverage what we're doing. And for us, we're working in a number of locations. So we're seeing sort of edge. We're defining something called the Goldilocks zone, which is basically where it's sitting between on-prem and metro areas, and in between there's a whole range of sort of things where data is created and content is consumed. So that's where we're seeing that we will be building, and again building with these guys here to help us sort of iterate what potentially the edge could be, which is definition very vastly different to depending who you're talking to. So that's what we're doing.
All right, so we had these questions we talked about. I'm going to not do those. So one of the things, the edge always talks about geography and definition and taxonomy and where. And I'm going to suggest, and then we're going to talk about customers and use cases, so it's kind of sort of what we talked about. But it's also a change in a business model, because if you look at Web3 blockchain technologies, inherently the democratization of technology. It's the taking it away from the core. You don't have to go to the big hypers or anyone. It's utilization as you need it, and then you're done and you're out, right? That's the whole idea around these technologies. And I'll share with you, I did a small edge deployment like 2016, 15. And the companies that I was working with, specifically the real estate, we're all driving towards, hey, we're going to need a 10-year contract. I'm sorry, what? This isn't a cell tower. This is a edge data center used for applications that come in and leave. No. It's got to be a 10-year contract. That's what the banks want. So I'm going to suggest that we're still entirely too tied to the greater data center industry. More importantly, the funding sources behind the data center industry that are in love with the hyperscale model and 5, 7, 10-year contracts. And the edge is something completely different, because our customers are, metaverse, blockchain, entertainment, fashion. They're not going to do the same thing. So how are you seeing customers talk about it now? And what do you think is the next commercial model, if you will, at the edge? And any of you can come up with their.
I'll take it first. I think Atlas has this distinction between proximity sites and aggregation sites, and I think there are those early use cases where people genuinely want that near-prem. I need something close enough, and I just light up some dark fiber between my premises and an edge site. But I think where we're coming from is that let's build the network with whatever compute, whatever type of workload that will tolerate the circumstances of building something in a district heating system or a swimming pool, and then over time it'll emerge. That said, there are already people who we're talking to who are genuinely want that. So gaming companies, the idea that you've got to be closer to all of those low latency use cases. Almost all of them, we have had a call from those people in the last 3 months. And that, I think, is a fundamental change. To be honest, I'm an energy person, so I'm learning the craft of data centers. So you all know more than me about how this world is emerging. But certainly, when we built a business 7 years ago, and we were heating people's hot water tanks with little computers. And Chris, who runs that business, still going. It's a wonderful business called Heater. And we were talking to Disney like 5 years ago, and we said, this great news, you can render your movies on people's hot water tanks. And they were like, fuck off. We're never going to do that. But then, like 2 weeks ago, one of the a large Soho post-production house calls us and says, please can we use Exmouth, the Exmouth installation? So those, I think, it is changing. I don't know.
Yeah, I think, as well as the gaming companies, I suppose that the big part at the moment is what we're seeing from people requesting about AI, because we've got the AI influence and batch running these processes. But then we're looking, so we're running a POC in Las Vegas with the OGA Open Grid Alliance, which we're founding members of. And we're looking at real-time or near real-time sort of analytics and data coming back from that. So we're looking for a slip and fall instance at the moment. The part of the POC will be built around that. But the times, with that low latency, it's how quickly can we act on that? How quickly can we do something? That becomes part of maybe something that then leads to triaging an incident. And again, it's that time to be able to resolve on it. You don't want the data to then skip through from where the incident happened to a regional metro area through to a central data center. You know, you want it to happen there now, and then people need to hear that. And I think that's what we're seeing a little bit with the AI, the speed at which we can deliver. So going from milliseconds, microseconds, and potentially nanoseconds. So yeah, it's quite interesting to see these user cases evolving, and AI is potentially a big driver for what we're seeing as well.
Yeah. This latency, this is your expertise, but yeah.
Well, and actually, before you, because I want to talk about Stelia specifically and how interesting the model is, and I'll save you from having to advertise yourself. But it's truly a pay-as-you-use bandwidth. So no, sorry if I'm signing contracts for you, but no port fee, because and I think we've all been around data centers with IXs, and you pay for the easement, you pay for the port charge, you pay for and it's all a contract, and that's where Tobias and his company is like, no contract, no MRC, you pay for what you use. And I think that all of you, that's you can pick up from here, but that's what's going to encourage people to go, oh great, yeah, now without that barrier to entry. So what kind of customers are you guys seeing?
Yeah, thank you. Absolutely right. I mean, we talk about us being, we're not the sexy, glossy front end to Web3. We are the plumbers, effectively. But without us, nothing works. So what we're trying to do is to enable workloads to go into edge locations in ways that typically isn't possible. So yes, we have a strong holding in a number of data centers, and that's growing into the hundreds around the world currently. But our strategy is to light as many edge locations at ultra high capacity, so 60 terabits upwards per site, to enable companies such as yourselves to then take full advantage of, well, my workload can be closer to the edge. That's a model and a market that traditional tier 1 telcos just aren't interested in or can't technically facilitate. So our position is that we are trying to enable edge locations and Web3 workloads to work with each other, and that can only be done over a highly flexible, highly elastic fabric that can scale very, very quickly into multiple petabits per second as a backbone, and then back down to nothing at all when you're not using it. And we're seeing CDNs right now adopting us as their backbone between certain sites because they can push enormous quantities of data out to an edge site and then not pay when they're not using the service. The commercial model is one part of that, but really enabling edge workloads, access to edge locations is really where our sweet spot is.
Go ahead, Andy.
Yeah, so Seagate, of course, is a 40-year-old company, right? So our needs are slightly different. We consider this to be the bleeding edge of the space, whereas we've got 5 factories that we've got to maximize production. So for us, the core large cloud providers are our big customers, and we have to think of them as we develop. So this for us is an advanced market that we're kind of moving into. But certainly our customers, certainly our realization was that so much of our business is centered on too few customers, very, very large data centers. And so our other customers are saying to us, you know what, we don't trust the cloud anymore. We want something different. It's too expensive. We can't predict it, what the costs are. So what can you do for us? And so we're seeing definitely a move back to on-prem. And somewhere between the cloud and the on-prem is the distributed architecture. So for us, it's very much in its infancy. It's growing, but it's still a place to put the hard drives that we manufacture.
Yeah, it's interesting. Actually, Loren, you helped me collar a very nice man from Microsoft, Alex, at a Tech UK event. I don't know, probably 3 months ago. But it's interesting that the hyperscalers are talking to us. They plainly see a need. There's this kind of notion of hyperscale edge, which might be a 5 megawatt facility, but certainly we're having a very interesting discussions with all of the big hyperscalers who they definitely see a need for it. I don't think they'd be wasting their time with us, wanting these sites if they didn't see their demand from it.
Well, no, I was just going to support your point. I think when you see, Azure sending a stack on site or GCP, and that's the dumbest thing in the world. Why would you send your stack on site? You can't service other customers from that. Why would you strand all that architecture? Now, of course, you're making money off of it, so commercially they don't care, but you can't convince me that if there wasn't a location within 5 miles, 3 miles, that they wouldn't rather put their infrastructure there and be able to serve everyone instead of being locked in. And that to me was one of the biggest arguments for, see, I told you, that's what they need. And I think, by the way, the other part of it is, when are we going to see applications built specifically for this distributed network.
Yep.
And it's the whole chicken and the egg, right? And are we seeing anything like that?
Yeah, I
starting to
think
happen?
you know, from that sort of element, as you're saying, you know, what we can offer is a true multi-tenant solution. But then this is where we're now looking at distributed decentralization, what's needed at the edge. So again, you know, we take drives from Andy, we can put them in a location with Mark, and we connect it with Tobias, etc. So we've now got a really keen sort of edge solution that we're delivering, you know, from that sort of side. But how it all comes together, you know, from that, you know, and it's a multi-tenanted platform. Which we then use to have like distributed systems. So, for example, we're working with Protocol Labs and Filecoin. You know, we can then have a distributed file storage solution. But then we also have a very open architecture on what we're looking to do and building open architecture so that other companies can come into this ecosystem and we can share data with them between there. So we're protecting customer data. So we don't own the data, they don't own the data, for example. And this is like the applications that can be delivered via the edge, you know, for long-term retrieval and archiving.
But those applications are really important. So you've got Kubernetes, in terms of the speed of the network, it's absolutely critical. You can spin up a Kubernetes container in like it can take anywhere up to sort of 40 seconds to spin up a Kubernetes container. The next version of containerization, what I sort of very bluntly sort of termed hyper-containerization, is Rust, is WebAssembly, all the technologies that the crypto and blockchain have pioneered. That's what the edge needs people to build applications in, because you can spin up a WebAssembly container in less than kind of 10 milliseconds, and it can be spun down, and it's zero trust environment. Its security is built in. So, but there are technology companies who are building Rust applications now. I mean, I spoke at a CIO event for Red Badger, who are good friends of ours. You know, top 3 e-consultancy firms. Stuart Red Badger, if he was here. They're not Red Badger. They're building Santander's mobile bank. I mean, they're the grown-ups in the software business. They are 100% committed to Rust and WebAssembly, and those technologies, as those technologies start to emerge, those applications are being written now. They're small. They're not, you know. But at that CIO event, you had Revolut. You had, you know, all the people you would expect to see and want to be building this type of. But we do need the software there. The software has to change as well.
We work with all the big private clouds and public clouds as well, both ways. I think we're at a unique tipping point in terms of Web3, whereby typically it's always people want to connect back to their workload. Now we've got workload providers saying we want to put our compute further towards the edge, and that the short answer to your question about Web3 applications, we're nowhere near there yet. But what is quite clear is that those emerging distributed applications do not work on legacy architectures. There's a number of people right now professing that they do and really trying to wedge them back on there because they're very concerned about these massive sweat distributed compute assets they've got that really aren't going to work in these modern environments. It is quite clear that in order to build things like Rust applications that will scale in milliseconds, you do have to have a completely different architecture in terms of compute, distribution, connectivity, performance.
Well, and I think, I mean, that plus AI, and we've got Skynet, so.
Yeah. Well, and that's this idea of aggregation sites. So let's not get in our own way about saying if an edge network has to run edge applications. If we can build a network with non-edge applications, let's do that. And machine learning and AI is one of those things, because most data centers can't immerse compute because it's too heavy. They don't want to do it. And so actually the edge plus AI is incredibly interesting, because you can do all the workloads that conventional data centers don't want to do. Happens to be that if you immerse compute, you can capture the heat much more easily, and so the whole jigsaw works, particularly for AI. But it's not an edge use case, right? So we saw a brief for a 5 megawatt ChatGPT instance that it's going to be running for 6 months offline. It doesn't. It's no one's ever going to need It's not latency sensitive in any way. But those applications we can use to then build out the network to kind of lay the ground.
Yeah.
On the AI piece, they're very slightly left field here. But the AI piece, we're integrating AI into protocol level. So things like QoS via AI. QoS is typically an awful protocol stack to be built, but there's now an emerging ecosystem of people actually directly building protocols using AI to shape the output of that. So that's a good example of it, really, with ChatGPT as well, their acceleration.
I think there was something, we had a conversation about that earlier this week as well, about, as you're talking about, how we need to make edge-aware applications, DApps, etc., and how AI, and this is a whole new territory, so again, there's a whole new raft of skill sets that's needed. We need developers, engineers that understand this, want to kind of start building it at the edge and doing this, and I think that's a whole new field, again, of where to concentrate skill. If there's a skill gap there at the moment, focus energies on there, learning Rust and learning about these sort of, technologies that can really make a difference, I think.
Yeah, I agree. And we're gonna make a pivot. You brought up heat reuse, so part of this panel was talking about sustainability as well as Web3 at the edge. And before I do want to note for the audience that none of you laughed at my Terminator joke. That was actually pretty funny. So sustainability. What do we need to do in terms of web? And we're going to bring in everything you just said. So throw away the script. Everything that we just said. How do we make sure that we maintain sustainability? Because it's only going to become more important.
Yeah. So I think, from our sort of stance at the moment and what we're doing, so, out there on our sort of, location out there, we've got our 3D printed server chassis. So again, there's elements where we're looking at that, what Mark was talking about, heat recovery, immersive technology. But from us, where we're looking at some of these edge locations, they can be quite remote. There's no personnel on site like a traditional data center to, if something breaks, fix something quick. So one of our aspects from this as well is about, maintaining the life of the equipment. So having it immersed, making sure there's no thermal shock means that we should be able to extend the lifespan of the hardware, means that the experience the customer gets, the uptime is improved, and there's less cost in sending engineers to site. So that's on a commercial element is a good thing for us. But also, again, that side of how we can reduce the power costs, what can we do with heat recovery, so there's a whole element coming out there. So it's not just one sort of element of the carbon sort of offsetting or how can we do that. There's actually a commercial value to doing this as well. Some people should be approaching that just as much.
Yeah.
I think it's a ground-up design across the board in terms of server, infrastructure, facility. The only way you can try and wedge sustainability back into existing sites and infrastructure and equipment, but it's very difficult to do. And you're making something that's inherently designed not to be focused on sustainability, more sustainable. I think in order to deliver true longevity of sustainability and being truly carbon conscious, and that's something you're incredibly passionate about, you have to start with a ground-up design of hardware, architecture, and services that's designed with that in focus.
Yeah, well, hold on, before Captain Swimming Pool takes over, I was going to say, the other part of it, if you look at just sending data, right? The tons of CO2 per megabit mile, it's just inherently more sufficient, more sustainable if you can only send it 5 miles instead of 150. Yeah. And that's where I think as we use commercial scenario is inherently more sustainable, because now we're not building infrastructure in order to get the long-term lease in order just to say we did it. We're doing it because it's needed. And we're also distributing the data and the applications to where they should be, instead of holding it all in one massive data center in Ireland.
Yeah, I mean, transmission networks are actually more electricity than data centers, right? Data centers are 3%, transmission networks are over 3%. So yeah, as you say, that in itself, just cutting those miles down is important. But also carbon is really quite dull. I mean, no one really understands it. I don't really understand it. I mean, Scope 3. When you try and explain Scope 3 to someone, I mean, it's not a pleasant experience, is it? So we've got to find much better ways of talking about this stuff. I mean, the best analogy so far we've got is a pint of Guinness. That if you're talking about electricity into your data center, that's the froth, that's the white head of the pint of Guinness. Scope 3 is the dark black bit, and no one talks about that. But 65% of the carbon budget of a data center is Scope 3, and then it gets really complicated, And you ask people who really should know, and they don't. So we're all trying to figure it out. But the trouble is, we are in a somewhat of an emergency now. So yeah, there will come a time when it costs a lot of money to waste carbon, and that's coming. I was at an event a couple of weeks ago, and if you run a data center over 100 kilowatts, you are meant to now be reporting your electricity usage as of the 1st of May, and how many people in this room know that? I mean, I didn't know that.
Yeah.
Yeah.
I thought they upped it to 500. Did they knock it
No,
back down to
they
100?
actually were going to go down to 50, but they got it. It's at 100. But
Okay.
but reporting is a precursor to pricing. Microsoft are pricing at $20 a ton for carbon. It's almost certainly going to be 200. And yeah, I mean, my math this morning was that if you own a 40 kilowatt data center in 20 years, and the life of it is 20 years, it's going to cost you $45 million to pay for to offset that carbon within 10 years. These are enormous.
Don't even get me started on offsets.
Yeah. Oh well, yeah, no, I mean obviously offsets, but somehow we have to mitigate it. Anyway,
Yeah. Well, let's hear from Scope 3 himself.
And isn't an offset of the carbon just moving the problem somewhere else?
It is, but
Yeah.
ultimately we can't recycle all of it, so we've got to do something with the bit we can't do.
Yeah, so I guess zero carbon is a bit of a dream, isn't it? Because we have activity, therefore we're going to produce carbon. And our view on the whole thing is you won't get change until it makes absolute business sense to do so. It hits the bottom line directly, and when it does, and when companies who have got financial stakeholders and shareholders and this sort of thing, when they can see a direct route to the bottom line, that's when you'll see proper change happening. And that's what it's got to be. We've got to be talking about really is how does it affect the bottom line, not necessarily just an environmental thing, because it's almost like a nice to have, isn't it? Oh, I'll get rid of my problem because I'm carbon offsetting. You're not. You're moving it to someone else. You've got to really drive the bottom line from it, and it's possible. By the way, it's not by no means a pipe dream.
I would say right now, it's not possible. And
I've got a presentation for you in about half an hour.
Well, I got a presentation to argue with too, but I'll save those. All right, so we have, call it 7 minutes left. As you can tell, this is a very informal panel. Does anybody have any questions or even comments to share?
Yeah, I've got a couple of points. So, Andy, to your point there, about it having to make business sense, the bottom line. Also, we should probably call out regulation, right? Because regulation can impact the bottom line and drive those changes. So some regulatory changes are going to happen in Europe lately.
Yeah, you're absolutely right. Yeah, the move to low power PSUs, for example, is the big one that's causing me the most problems right now. But yeah, absolutely.
Cool. And a quick one for you as well, Mark. You touched on this previously. You were talking about hyperscalers. So the hyperscalers are now looking at these more energy efficient technologies. How have we seen that change over recent years? What's their willingness to engage like now compared to say 5 years ago?
I mean, it's still very logical to build a massive data center in the middle of nowhere, right? No, it still doesn't make sense for the current data center industry to look at different models. But certainly our perception is there is a much greater willingness to experiment and to give them their dues. Microsoft and others have started to do that, right? They. And actually, it was Microsoft who wrote the 2011 white paper about data furnaces. So they have been leading there, but again, it's got to make economic sense. What's frustrating is that when you arrive at a conference and someone says, "Oh, it's more expensive to reuse the heat," it's definitely not the case, because if 30% of your cost is cooling and you don't have it, we are living proof that it's definitely cheaper to reuse the heat. So there are a lot of misnomers, I think. And I think as large organizations get their head around that, certainly our perception is that it's changing. How fast? I don't know.
I do challenge your comment that building great big data centers in the middle of nowhere still makes sense. The only people that really make sense to is the financial group. Yeah. Because they love how neatly it lines up with their expectations of ROI, and I take this opportunity, because I'm not fundraising currently, to bash them for their bad thoughts.
Yeah, but humans are humans, right? We're habit. We're creatures of habit. So doing things differently is effortful. It's difficult. It takes time.
Yeah. Well, and especially when you think about what you're doing. You're inherently a brownfield. So you're taking something that already existed with all the embedded carbon, and reusing it and retrofitting it to something else, instead of bulldozing everything and digging 6 feet down just to create a massive structure that could have been somewhere else that already existed.
Yeah. And that ultimately, that logic will take hold. Yeah.
Anybody else? Questions, comments? Excellent. Any final thought? Okay, actually, last question. 5 years from now, we're having the same panel. What has changed?
Someone might know what edge is.
Yeah, defined it by then.
I think the definition of edge is important, right? Because we keep talking about Web3 being edge enabling or vice versa. I think the definition of edge and true edge will become clearer, and there'll be more of what you are doing with distributed edge. And I think we will see a lot more in terms of application development focused towards edge focus rather than edge after. We're already seeing enormous shifts in organizational compute load moving out to the edge. We're seeing enormous requirements for that too. So I think that will become, in 5 years' time, there will always be the big internet strongholds in terms of your mass facilities and data centers. But we already have the big public clouds leading the way in terms of asking for edge distributed compute and HPC. I think that'll become a normal in the next 5 years.
Yeah, I'm going to get way more bullish than that. I mean, in 5 years' time, half the data center state in this country will be heat reuse. By 2025, everything in Germany you need to heat. You need to reuse your heat, or you won't be allowed to build a data center. So in 5 years' time, I'm going to say the first smart cities, massive greenhouses in the middle of smart cities. The whole notion of heat reuse and sustainability will be. I think it will have accelerated a lot. I mean, you'd expect me to say that, of course, but. Yeah, I mean, in terms of our roadmap, if we hit our numbers, I mean, yeah, and I fully intend to hit our numbers, we will be the largest data center in the UK, the greenest, and yeah, and we should be enabling a complete reboot of our local economies. Yeah, let's be positive about it.
Yeah.
I think.
Please. Yes.
So in Sweden,
Yeah.
you've got heating grids.
That's right. District heating systems. Yeah. Yeah. Yeah.
In places like UK, then.
We've got 11,000 of them in the UK already. Yeah.
Are you thinking that there'll be more like
An explosion of them.
on-prem?
Yeah. Yeah. Well, and near-prem.
Yeah.
Yeah, but there are 11,000 district heating systems in this country already, and we've got, even since in the last 3 months, we've got 7,000 megawatts of sites that could take data centers. So we could already deploy 7 times, is it 7 times, 2 times? A lot more data centers that we've currently got in this country. We could already deploy to heat reuse.
Do you use heat pumps to...
No. We're prime. Yeah, district heating systems. We can plug. Oh, sorry, district heating system. Yes, we prime the heat pump. That's right. We make the heat pump massively more efficient. In swimming pools, you can just heat the pool directly.
Yeah, because I read recently that you can reheat data center heat up to 60 degrees with a single heat pump.
Yeah,
If you
yeah.
series, you can get up to 150 degrees.
That's right. Yeah, I mean, of some direct-to-chip, Matt's in the back who can talk more eloquently, but direct-to-chip, you can get nearly 70 degrees off the computer. So yeah, we need chip manufacturers like the reverse Moore's law, make them as big and as inefficient as possible. Knock yourselves out, you know.
No, that's not. Andy, go ahead.
It's very hard to predict for 5 years, let alone sort of next quarter. However, I think that we'll have DNA storage. It will be much more commonplace. And if you think about, so our version of DNA for storage is that you can put the whole internet as it is today in the size of a beer barrel. So massive capacity in a very small space. That's what we think we're working towards.
All right, well, I'll throw my lot in. Wait, did you go
I was
yet?
just to say, yeah, it's probably over that sort of time period. It's about this infrastructure that we're building at the edge for people to come over the top and develop is about the amount of innovation that we'll also have. So in 5 years' time, we'll be talking about applications, services that have been built that we can't even think about at the moment. It'll all just gradually appear.
Yeah.
Amazing sort of AI to AI, human interfaces, and all sorts of things. And that's probably another key bit that we're enabling as infrastructure providers is the guys that really smart people to come over the top with the innovation, the ideas and concepts to build and deliver. And I think that's the other bit that we'll see in 5 years.
All right, so I've got 30 seconds. I'll throw in and say, I think now that Meta's gotten out of the way of the metaverse, and they were never going to do it anyway, we're going to see an explosion of really innovative, creative applications that are going to start edge native. I call them edge native applications that are meant to roam and live and traverse. And that's it's not going to be anybody big. It's going to be, the creativity of people we don't even know exist yet. So, all right. And there it is.
Thank you.
Phil. So thank you to the panel and thank you to the audience.